we were about to build a transaction. We've now got all the ingredients that we actually need to get started. The first thing we want to do though is we actually, in order for Alice to send money to Bob, Alice needs to have money. Alice doesn't have any money right now. And how does Alice get money? Well, if you recall in the node setup video, we played around a little bit with the inbuilt wallet inside the node software, and we still have 49.99 something test net bitcoins in that wallet. So what we can do is we can send some of those bitcoins to Alice's address, right? So that's where we will start. We'll start with Alice actually receiving funds into her Bitcoin address, which will then allow her to send some of that money on to Bob's address. Yeah. Switch over to proper code window, get into my terminal. Okay, clear this. Okay, so Bitcoin CLI, I've got my Bitcoin daemon running locally already. So if you recall, when I sent money to a recipient address, and I basically, okay, I'm not going to send, I'm going to send 10 Bitcoins. I'm not going to send 100 Bitcoins from a wallet that has 49 point something Bitcoins in it. Actually, let me quickly confirm the balance, right? So if you recall, we had the get balance transaction. Bitcoin home isn't configured. I rebooted my computer last night. Okay, so let's set Bitcoin home environment variable to be our current working directory, right? Which means that I can then run Bitcoin daemon and get the balance for my current running wallet, which is now empty. Oh man. Okay, all right, so no problem. I will just generate 101 coins as I done before. I've once again got 50. I can now spend from this wallet. So I'm not doing magic. You can look at the previous video if this stuff seems like if you didn't get what I just did. That would be the Bitcoin node setup video. I talk a little bit about the CLI tooling in there. Right, so this wallet now has some coins in it, but we really want to send some coins. So I'm going to send 10 coins to Alice. Now, what is Alice's address? Let's go and have a look. Right, so this is actually Alice's address, if you recall. Right, so we printed out Alice's address, and this is actually her address. So I will just paste her address into the terminal window down here. Let me make that a little bit larger, and that should be it. Once I send this money, now importantly, once I send this money from the node wallet to Alice's address, receiving address, there it's gone through. The node wallet doesn't have that money anymore. Now I'm going to grab this transaction ID before I do anything else. The transaction ID is going to be important for us to be able to, if nothing else, I'm going to annotate this and say Alice receiving funds. This is her TX ID. I'll explain this in a second, right? Transaction IDs, etc. Okay, so I'm going to get the balance on my local wallet. There should only be 40 Bitcoins. It's about 40 minus the small amount of Satoshis that basically went to the miner. Now, there's one more thing that I should mention, right? That address that got generated for sending the coins is right now still in the mempool. It hasn't actually been mined. So I need to mine at least one more block before those coins are actually in the blockchain, in the local blockchain. So I'm going to generate just one more block, which generates a new transaction ID, right? And because I now, if you recall from yesterday, my expectation now is that I should now have received another 50 Bitcoins of from a Coinbase transaction. It would be the second Coinbase transaction now that I've got 102 blocks mined, right? So that's what I think needs to happen, and we can confirm that. There we go, right? We now have 89.9 Bitcoins in our local node wallet because we just mined another block, and that has essentially given us access to the coins from the second Coinbase transaction. All right, we need to talk a little bit about transactions first. Let me switch over to my browser window. Okay, so before we do that, Alice now has 10 Bitcoins in her wallet. And we need to talk about transactions, and then I'm going to talk about this idea of saying that she has money in her wallet. It's not correct, right? We'll talk about that in a second. Let's look at the browser quickly. If you go to the two-stack developer guide, go over to Bitcoin nuts and bolts, and I want to look at transactions, right? The first part of the transaction documentation talks about the transaction data structure. Now, until now, sorry. Until now, I've just been throwing this word transaction out there. Now, if you're watching this video, if you are a Java developer watching this, you would probably have realized that, yeah, this transaction you're talking about is probably different from the transactions that we normally think of, right? It's not a transactional boundary that we're talking about. This transaction is something else. In Bitcoin speak, a transaction really is a data structure. It is the data structure that encapsulates this particular format. Now, the format that the data structure, the format that this particular data structure has is documented here. Essentially, transactions have a version number. There is a number of inputs and the number of outputs. And then there is a lock time at the end. I won't explain each of the individual fields in this video, but the documentation does go into the details of what it is. They are explained in the documentation. So if you really want to know the relationship between things like the lock time and sequence numbers, and the explanation of the individual fields, please go and read the documentation. For our purposes right now, we just need to know that a transaction, when we speak of transactions in Bitcoin, they are a different kind of transaction. It's a data structure. It's a transaction data structure, and the data structure is something that we're going to compose. We're going to compose it using inputs and outputs. Typically, the way that we construct the data structure is that we need to, okay, before I say that, I need to get back to what I was saying before about this idea that Alice has received money in her wallet. She hasn't. Alice's wallet contains only public and private keys. The actual coins that Alice has access to are on the blockchain. What Alice has is a set of keys that allows her the exclusive right as the holder of those keys to move those coins from one transaction where it is currently in the output of a transaction into a new transaction where those coins will be living in the output of a new transaction. Inputs and outputs in Bitcoin terms, oh man, sorry, I need to practice more speaking like this. Input and output transactions. Wow. In Bitcoin terms, inputs and outputs are, I've lost my train of thought. Inputs and outputs are essentially also referred to as unlocking and locking conditions respectively, or locking or spending and locking conditions. When we moved funds from the Bitcoin wallet to Alice's wallet. That's one way of saying it. What we can, another way of saying it is that in transaction terms, we have actually moved, we've actually just created or done a bit of accounting on the blockchain, whereby money that used to be in the local in one account is now in another account, and only the person who has access to that particular account, which is denominated as an on-chain transaction, is actually allowed to move the funds. And you can move the funds back to yourself, or you can move it to somebody else, right? Right. So that is an important distinction that I needed to make, which is that the relationship between inputs and outputs as they relate to locking and unlocking, or spending and locking conditions, that particular abstraction has been encoded in the transaction builder, which we will now create. Now, Alice would now like to move, or rather Alice would like to instruct the blockchain to move money from her account into Bob's account, right? I prefer that language. It's technically a little bit more accurate to think of it in those terms than saying moving funds from one wallet to another, right? So I'm going to try and say now, we're trying to move money from Alice's account into Bob's account. In order for Alice to authorize the movement of the money, she needs her private keys. Right. We're going to move money between the accounts. And to get started, we need a transaction builder. Right, so I'm going to, okay, let me import the transaction builder class quickly. And I'm going to say that I want a TX builder of type transaction builder is basically going to be just invoke the constructor to create a new transaction builder. The transaction builder will need to send money from one transaction to another. So I'm going to say TX builder. So the TX builder actually follows a builder pattern. So I'm going to say spend from transaction, and the transaction that I'm going to spend from is Alice's funding transaction. So I'm going to say Alice funding TX, which doesn't exist, and we want to spend from an output index. I'm going to guess now that the output index is 0. The sequence number is going to be the nlock time max value. Not going to explain that now. And then we need some sort of an unlock builder, or a helper class that will allow Alice to actually authorize the movement of the funds from her account into Bob's account. Now, you would have noticed that we now have two things here which are missing. We have this unlock builder, and we have Alice's funding transaction is missing. Alice's funding transaction is why I grabbed this transaction ID before. So I need to instantiate, I need to create an instance of Alice's funding transaction, which is going to be a transaction. And this transaction, I'm actually going to read in the raw transaction, right? So I'm going to create a Alice funding raw TX. It's going to be a string that I read in, and that string I'm going to ask I'm going to ask the local node to actually give me the string associated with this transaction ID that I made a copy of before. Now, if we are going to interact with the public node infrastructure, we will still need a raw transaction eventually. We will still work with transaction IDs. The means by which we obtain the transaction IDs and the raw transactions will just be slightly different. We will probably be interrogating a public API to send a transaction, and the public API will actually, so let me back up. The transaction ID, this data structure that we looked at before, right? The transaction data structure, you will notice that there is no field for a transaction ID. the transaction ID is actually just a double SHA-256 hash of the byte code of the byte serialized data in the transaction, right? So that is basically what the transaction ID is. So let's go back here. So we can once we have created our transaction, we already know what the transaction ID is going to be. The transaction ID is not some primary key value that is held in a database somewhere that is assigned to us by a third party. Our transaction ID is essentially the hash of the transaction that we've created. And these transaction IDs will generally be unique. Special conditions exist, but assume that transaction IDs are unique always, because the serialized version of the transaction changes if you change, even because it's a hash, right? It's a double SHA-256 hash. So the serialized version is pretty much unique. Okay, so we need the raw transaction data, which is essentially the raw data structure that has been serialized and then encoded in hex format. Where do we get that? Well, we need to go and ask the Bitcoin node, our local Bitcoin node, to actually get us the transaction. There is a command, a RPC command, that we can issue to the local node using the Bitcoin CLI program. So I'm going to I want to get raw transaction, and I'm going to give it this transaction ID, and then I'm going to ask it, tell it to me. Okay, big string, long list of stuff right there. Okay, so that is actually the data that we want. That is the raw transaction. I'm going to paste that into my program, and now I have, I need to reconstruct from Alice funding raw transaction. Okay, so now, okay, we have now reconstructed the Alice's funding transaction from the raw transaction data. Let's get back to putting together the transaction builder. Okay, so we have set up the funding transaction. We don't have this unlock builder yet. The unlock builder is essentially something that Alice needs to construct. So there is a class called unlocking script builder, or rather that's an abstract class actually. So I'm going to say that this is, shall I call it just unlock builder, or maybe, okay, I'll just call it the unlock builder because we'll only have the one, which is an unlocking script builder, and I'm going to have a very specific instance of this, which is a paid to public key hash unlock builder that we are going to be creating, and we want to create this from Alice public key, right? So we're creating an unlocking script builder from Alice's public key, which will create the correct spending conditions that need to be signed. Right, so TX builder, we're basically spending from there. That returns another instance of TX builder, so we can just keep pending this. And we then want to say we want to spend to receiving to, I'm going to say to Bob receiver. Right, so this is going to be Bob's, let me call it Bob locking builder, because it's going to more accurately represent what it actually is. And we want to spend, how much money are we going to send to Bob? how many Satoshis? I'm going to say, okay, let's send Bob 10,000 Satoshis, right? And now we need to go and basically talk about why. I just realized that it's again me with the semicolons, right? let me get rid of this window down here. So Bob, we're spending to Bob's locking builder, or rather we're using Bob's locking builder to lock up the coins. So when we construct this new transaction is going to have outputs, right? So there are two transactions that we're working with here. We're working with two transactions, two data structures like this. The first data structure that we're actually working with is the one where we are spending the coins from. Let me see if I have a graphic that actually shows that. Here we go, right? So we basically have, we can think of this as, of us now having two transactions. And the two transactions that we have is essentially let me see here. Let's say that the transactions we have are the one that Alice has, or rather the transaction that Alice now needs to refer to is the transaction that is currently in the blockchain. So that transaction would be in block A. We want to send a new transaction that's going to be created in block B. Let's say that that transaction is transaction B2, and that transaction B2, which is the one we are creating, is going to need to reference the transaction that currently contains Alice's funds in transaction A4. So we have two transactions that we're working with. We called the one in A4 Alice's funding raw TX, and the one in B2 is the one we're actually building right now with the transaction builder. This distinction is really important to note, and I've noticed that a lot of other tutorials actually are not very clear about the fact that these two transactions are different. So when they talk about the inputs and outputs, I found it hard to keep it straight in my mind. Which input are we talking about? Which output are we talking about? Now, if we look at the code that we're constructing, so remember that I just mentioned that the Alice's transaction is the one on the left-hand side. Bob's transaction is the one on the right-hand side. Or rather Bob. Alice's, the transaction that contains Alice's funds right now is the one on the left. The transaction where we want to allocate funds to Bob is the one on the right. Alice is the person who needs to create the transaction on the right-hand side because the funds are locked up using her keys. Rather, she's the only one who can move the funds from the transaction on the left to the transaction on the right. When she moves the funds from the transaction on the left into the transaction on the right, she will essentially create an output in the transaction on the right. So if you go back to the transaction data structure, right, she will create an output, which is this output here, which will be in the list of outputs in the transaction on the right. And that output in the transaction on the right, one of them will essentially be an output that only Bob is able to spend from, right? So Alice moves money from her output in transaction on the left and basically allocates that money to Bob in the transaction on the right, and the rest of the money she'll create a second output and say, okay, the rest of the money is going to come back to me, and then a certain amount of funds are going to be sent to the miner as a fee, right? Okay, so I hope that is clear. If it is unclear, hit me up in the comments below, as the kids say. All right, so we want to create Bob's locking builder. Now, Bob's locking builder is essentially going to be the helper class that creates the locking conditions for the output, that generates the output transaction, that generates the transaction output for the transaction on the right that belongs to Bob, right? So Alice will construct that from Bob's public key. So at some point we're going to assume that Bob gave either his public key to Alice or he gave his Bitcoin address to Alice. either one of those two will suffice for Alice to be able to reconstruct Bob's or to construct Bob's locking builder. Right, so we're going to say, well, Bob locking builder, which is locking, an instance of locking script builder, and it's going to be a pay to public key hash lock builder for Bob, and we're going to pass in Bob's address, right? Just give Bob's address, because the pay to public key hash locking condition only needs a hash of Bob's public key, which is encoded in Bob's address, right? And so that's where we are spending to. Now that we have said where we are spending to, we can also say where to send change to, because remember that the transaction on the left that Alice is spending from contains what? How much do we send? 10 Bitcoins to that transaction, to that account. Alice is going to send 10,000 Satoshis, so a relatively small amount, to Bob, right? In order for that to happen, there's going to be a huge amount of Satoshis left, right? There's going to be like 9 Bitcoin and a lot of Satoshis left over from Alice's initial balance of 10 Bitcoins. So the rest of that, Alice would ideally, Alice wants to get that money back. So she will send the address back to her, she will send the money back to her own address. So she basically she'll say, okay, send it back to my own address and use a locking script builder to generate an output that I'm allowed to spend from me, Alice, right? So Alice lock builder is another locking script builder, which is also an instance of pay to public key hash builder, but using Alice's originating address. So Alice is sending the change back to herself. This is not strictly necessary for us to specify that we want to spend with a fee, a per kilobyte fee of 512 Satoshis per kilobyte. I'm putting it in here just so that we're able to actually generate, just so that you know that it exists, so that you can go and look up the documentation or the API docs for you later, right? This method, the transaction builder, so rather the build method, is sort of the final part of the transaction builder. Once we invoke build in the transaction builder, we're actually getting a transaction out. So I can say this is the spending TX, which is an instance of transaction, is coming from the transaction builder now. Now that we actually have this transaction, the transaction lacks one thing. In order for Alice to successfully move the money from her account into Bob's account, she needs to sign this transaction using her private key. So let's do that now.